Hello, good morning. I'd like to welcome you to the Myra Technology webinar. It's on Is Regulation Slowing Down the Advancement of Connected Autonomous Vehicles? We have a chat function for you to introduce yourselves and generally network on the, if you click on the chat at the bottom of your screen, then you should be able to talk to each other. There's also a question and answer button there. Please submit your questions as early as possible, because then we might be able to answer them live, or we can choose to answer them at the end of the session. If we get a lot of questions, then don't worry, we'll answer them and send out the feedback straight afterwards. We are recording this session, just to let you know, and that's so that we can make it available to you afterwards on our website. So please go look on our website and you'll find a link to this afterwards. I'd like to introduce you to Dr. Huw Davies. He is the Assistant Professor at the Research Institute for Future Transport and Cities. He'd like to discuss how the automotive sector should work together to advise on and lobby for the frameworks that will help us streamline innovation and product development in this area. So I will hand over to Huw and I will talk to you in a bit.
Okay. Well, thank you for that, Lisa. And, let me do some sort of formal introduction first and foremost. I'm Dr. Huw Davis. I'm a deputy of the CAV team at Coventry University, which in partnership with Myra is a member for the Centre for Connected and Autonomous Vehicle Research, or CCAV. Just a bit about my background, because I think it's quite diverse from my own perspective. Before joining Coventry, I was an academic at Cardiff University. And whilst there, I established what is still going, which is an electric vehicle centre of excellence. This centre really was unique in itself in that it focused not on technology development per se, but really focused on the role of technology in a larger and more complex socio-economic system. Amongst other achievements at that time, we were part of a steering group set up by the Welsh Assembly government, and we contributed to their position paper on electrification of road transport. Prior to that, I was involved as part of a team at the UK Transport Research Laboratory concerned with the development of the next generation of vehicle crash tests, which incidentally also supported my doctoral studies. And if you care to go even further back, if you so wish, then I started my career in the UK motorsport sector with companies such as G-Force Technologies, that was famous in my world for building the Thrust SSC, and also with Reynard Racing Cars, which has morphed somewhat into the Mercedes Formula One team, rather a tortuous route. So why am I here? Well, I could argue that I find it difficult to say no to an invite. I could also say that my colleagues at MTI are also rather persuasive. But on a more serious note, my research interest and really what drives me forward is the automobile, and beyond that, the wider mobility system. So how the automobile provides part of the mobility system. Initially, from my background, I was concerned around safety. It then migrated to include really the impact upon our environment. And more recently, and in response to the above, the development of connected autonomous vehicles or CAV, because they can address both that environment issue and that safety issue at the same time. My interest really has been and always will continue to be not really in the technology itself. I am an engineer, by the way, so I come from a technology background, but in the way that we manage the development trajectory of that technology so that society is not disadvantaged, but that society, in accepting really that the automobile is going to be part of that society, it can succeed, and that we don't realize what I've put on the slide there, that basically the car wipes the world out. I hope it doesn't, and I hope we can do the right activities to make sure that scenario is not fulfilled. Upon arrival at sort of Coventry, one of the first articles really that I wrote relating to connected and autonomous vehicles, and which was kindly published by the IMechE, was around technology failures and the hype cycle. And the basis for this discussion was my previous experience at Cardiff University with the fuel cell vehicle and the initial hype that this technology solution received in the mid to late 1990s, and how that technology at the time was still failing to deliver. It was under-delivering, so to speak. I did really consider at that time there were certain parallels between the two technologies, that is the fuel cell vehicle and the connected and autonomous vehicle. And in both cases, the technologies we're being touted as a solution to some of the problems that plague society as a result of our continuing love affair with the automobile. For fuel cell vehicles, it was the dual issues of pollution and energy security, whilst for CAV, it was really focused on that eternal problem that has continued to perplex many, which is basically providing a safe mobility system. A case really of having our cake and eating it, being able to move around, but being able to move around in safety. In both cases, it was not the inability of that technology to deliver per se. We can see developments in both those technologies. We're all involved in the sort of research side. But I really think it's the ability of the technology to unseat the incumbent system that is the issue. And, I'll come back to this point a bit later on. But suffice to say, it is my belief that technology alone does not necessarily deliver change. I mean, we've got plenty of examples. We can take supersonic flight from the 1970s as an example. But coming back to the article, there were some comments on the articles, and what I was perhaps not expecting was that regulation is slowing down advancement in technology. This, from my background, was surprising. But upon reflection and a little bit of thought, I maybe come to a different point of view that perhaps not that unsurprising. And that's really why I want to target this webinar, because I want to explore this idea, this juxtaposition between my view of regulation and perhaps the view that many of the wider society share about regulation and its impact on industry and how we can manage that going forward. So firstly, I'd like to basically just make a distinction. I'm talking about regulation primarily, and there are regulations and there are standards, and there's a slight difference between the two in the sort of nexus they target. And if I'm talking about regulation, my simple view of regulation is that it imposes upon both private firms and individuals requirements that achieve a government's purpose. And when I speak to students, I say to students for the automotive sector, this distills down into two key areas. Yeah, we can argue there's probably more than two, but it's, for my mind, there's two key areas. One is providing a minimum level of protection of the environment, and the other is to provide a minimum level of protection for the user. And by user, I don't mean just the person sitting in the vehicle, I mean anyone who has to interact with the transport system, right the way down to the pedestrian. And I also want to highlight that I choose that word minimum deliberately, and I will elaborate on this perhaps later in the presentation. However, if you want to read more about regulation and how we got to this point, then, bit of salesmanship here, I can recommend the following book, in which I co-authored the chapter on vehicle regulation with my colleague, Dr. Paul Nieuwenhuis. But the question today really is, and I hark back to that comment on the previous slide that continues to haunt me to this very day, is it inherently bad to have regulation? Ever since the first major regulations for the automotive sector were enacted in the 1970s, there have been concerns expressed about their potential impacts on business. From a traditional perspective, regulation exists solely to correct for, i.e. to internalize, the negative externalities of our transport choices. And hence, necessarily, it has at times led to a negative impact on efficiency and competitiveness of the industry. I admit that. You only have to look back, and I love reading books on automotive history, and the British sports car, or the death of the British sports car in the 70s due to American regulation, is a good case study. However, I also have an alternative. I call it a revisionist view that suggests that regulation can actually stimulate competitive advantage. And you can do this through efficiency improvements, through driving innovation, through opening up new market opportunities. And it's my experience that I tend to favor the latter. But, maybe you shouldn't just take my view of this. Maybe I should, in the best of academic practice, maybe I should give you some evidence as to why I feel that this revisionist view is the one we should be looking at. And, perhaps the best example I can come up with is the emissions. In 1998, the European Automobile Manufacturers Association, ACEA, together with JAMA and KAMA, the Japanese and Korean automobile manufacturers associations, respectively, they agreed to reduce CO2 emissions from new cars sold in the European market to 140 grams CO2 kilometre by 2008. However, the automakers' commitments lacked really any binding burden sharing. And as it became clear that neither that 2008 target of 140 grams or the subsequent 120 grams target for 2012 would be met, the Commission then announced it would be putting in place mandatory reductions, i.e., it would be regulating. Beginning with this Commission's announcement, the rate of reduction in specific CO2 emissions from new passenger cars began to rise sharply. The trend was very clear. There was a correlation. Switching from a non-binding voluntary industry commitment to a binding regulation spurred innovation, and significant reductions in CO2 emissions were the result. And, that's a very brief synopsis, but you can find further studies that bring in patent filings, which show the level of innovation, and they match up with that same timeline. But the interesting thing here, and that may be overlooked, is that subsequently, these targets that have been applied in the European market tend to basically cascade down into other markets. And in those other markets, if the players in those markets want to meet those targets, they have two choices. They have a choice of basically innovating themselves, which obviously takes time and investment, or they can look outside their market for innovation that's already been developed in response. So they look to markets like Europe that have already responded. And therefore, that IP that in the domestic market has been generated from responding to regulation has a monetary value. It has a value to that company that can be realized by selling that IP into other markets where those regulations are being cascaded down into. And there's a famous quote there from Port and van der Linde, which is, by stimulating innovation, strict environmental regulation can actually enhance competitiveness, and that's of industry. And if regulation has a benefit for innovation, as mentioned on my previous slide, then, the next step is for alignment of regulation across markets. And in the automobile industry, the OEMs, they have basically promoted this regulatory conversion and harmonization, because if they're going to have to accept regulation, then convergence and harmonization has a benefit for them. And these benefits can include, as listed there on the slide, reduced costs, because you can basically have larger production volumes of a single product, certification, you have less certification, better inventory management because you're selling a similar product across multiple markets. You can have more efficient allocation of resources. For instance, more resources can be used directly for R&D instead of double testing, with perhaps limited benefit to safety or environmental. Or you can realize that saving and you can pass it on to consumers as lower prices. Also, having similar convergence and regulations in different markets means you have better choice for consumers, and it makes the latest technologies available quicker to those consumers. And finally, it can increase trade with other markets that share the regulations, and this can lead downstream to increased foreign direct investment. Or to put it another way, looking from the other side, my view is that if we have fragmentation and market-specific regulations, I think this will increase costs and ultimately slow down development of new vehicle technologies. And in that term, new vehicle technologies, I include connected and autonomous vehicles. Now, the question really is, can this revisionist model be applied to connected autonomous vehicles, i.e. where regulation and innovation are mutually supportive and combine to accelerate the system development and the system acceptance? Or is it the case that the traditionalist model, as made in that comment to my first article, is that the dominant model, and therefore regulation will have a negative impact on the efficiency and competitiveness of our developing industry? I suppose really the ultimate question is, how can we ensure that we can be successful? Now, I'm an avid reader of automotive history. I get some my wife says I get some strange books for my Christmas and birthday presents. And one of those books I was reading recently is What Comes After. Funnily enough, the title is After the Car, written by two UK academics about a decade or so ago. And they included a quote in their book from the renowned science fiction writer, Arthur C. Clarke. And he wrote about automated cars and a future singularity where driving a non-automated vehicle on the highway would be an offence. So he was talking about regulation, enactment of a law, which meant that in order to accept new technologies, we have to basically exclude the old technologies, which, that's one argument you can make. But really, this got me looking further. I was aware of the Futurama exhibition from GM of the 40s and 50s, but it's amazing what you find when you are looking. And I'm sure some of you on this webinar have already aware of this. And it's not really the text that is interesting, but I've included that for sort of for your own reference. It's the date. And the date is 1935. I mean, we're talking almost a century ago now that we was first talking about automated and driverless vehicles. Why were we talking about them at this stage? Well, the world, and especially the US at this time, was undergoing rapid motorization. And there was a realization that with rapid motorization came fatalities and serious injuries. And one of the statistics at the time was basically after the World War I, in the 4 years following, there were more fatalities on American roads than there were Americans killed in France during the entire First World War. Now, there was realization that the driver was driver error being the prime cause of these accidents. That infrastructure and vehicle design were also critical factors in causation, and severity was at first little acknowledged. It was in its infancy, the industry at this time. And therefore, the idea really of substituting error-prone humans with technology really thus practically suggested itself. It's nothing new, is what I'm trying to put forward. So the question is, if we were talking about this almost a century ago, then the valid question one must ask is, well, why the delay? Why are we sitting here in 2021 now discussing CAV and regulation of CAV? Well, if removing the driver really was recognised as a potential benefit to reducing injury-causing collisions, then surely by not acting for this amount of time, we're leading to greater harm to road users. Well, not necessarily, because to put simply, it was easier without the technology to hand to solve the problems of safety really in other ways. In improving system performance, it's often easier to compartmentalize and solve problems at component level. And this is good because it makes a very substantial link between cause and effect. And that is very good when you're talking about policy and the success of policy. You do something, you can see a direct result of your action. Thus, the focus shifted to vehicle design, to highway design, and to the driver or the user training. And these were ultimately more accessible, and to a large degree, the changes, if not really extensive, had limited impact upon the behavior of that larger complex mobility system. I'll give you an example. A safer car could circulate with a less safe car as long as they adhere to the same conventions. Road infrastructure improvements were universally shared across all users of the transport system. We teach vulnerable road users to behave differently around traffic, etc. So we were basically fiddling around the edges, but we were basically not changing fundamentally the way the transport system operates. So if we were quite happy to move along this path, why the continued focus on CAV? Well, aside from the safety angle alluded to previously, we're presently having to deal with many global megatrends associated with mobility. You've got the increased demand for mobility within a finite infrastructure. Urban populations are increasing, leading to additional, if not less, demand for mobility in these confined environments. And depending on what text you read, and I just picked out some from the literature, I took the literature to be informing me that CAV is expected to conservatively increase utilization of existing infrastructure assets anywhere between a factor of 3 and 4. And further, CAV will also drive up the energy efficiency of the mobility system. This is a requirement if we're likely to be able to meet national and international targets in areas like greenhouse gas and air quality. something really that the present mobility system as it is structured is ill positioned to deliver. Finally, I think it's important that we recognize the economic benefits, like the investment that Honda's making in the slide there, 2.8 billion into self-driving cars. You know, you ask me that question, I say maybe the return on the investment will take a little while, but ultimately, I think if you're not in the race, then you will probably lose out in the long run. Hence, widespread commercial adoption of autonomous vehicle technology promises really to deliver to us a wide range of social, economic and environmental benefits. And whilst the magnitude of these benefits is really difficult to predict at this stage, the existing research really suggests the net impact of autonomous vehicles will be significant. There is no counter argument to that I can basically see gaining any sort of traction. The problem really is when we try to basically put those autonomous vehicles into the mobility system. And this is where, regulation can be our friend and not necessarily our enemy. The problem with the mobility system is that they are complex systems. We also have to acknowledge that these mobility systems are not in balance, no matter how rule-bound they appear to be at first sight, having to drive cars and adhere to the rules of the road, or having to be a pedestrian and adhere to some rules of how to use the sort of transport system. They adapt and they organize through time. Further, through their inner workings, they can generate both unpredictable features and unintended effects. Put simply, and as an example, by creating an accessible mobility system in the first place, we created demand. And this increase in demand exacerbates those negative externalities. Additional road capacity quickly becomes saturated. Emissions improvements at the vehicle level, which is what we've been doing up to this point, are quickly negated by increasing vehicle miles traveled. And one that's probably closer to home is the promotion of diesel for greenhouse gas reduction has actually inadvertently led to a poorer air quality and air quality issues. And I could go on with many, many more examples. But ultimately, what was successful previously in the way that we tackled problems and externalities of the mobility system is probably not going to be sufficient going forward. We have the demand, we have the environmental, we still have road accidents, by the way. We still, road transport counts for about 1.25 million deaths per year. And we've also got to account for the non-fatal injuries and the economic harm. So mobility systems, really, they're always balanced on a knife edge. And perhaps now we've exhausted many of the other avenues, many of the simple fixes, the time of this automated vehicle may have arrived. The question is how to manage its introduction. Do we allow a free-for-all? Or is this where regulation can support? And indeed, I believe that if done carefully, we could even accelerate the system deployment. So if we introduce CAV carefully with the support of regulation, we can actually accelerate the trust and acceptance of the connected and autonomous vehicle. So this is and the emphasis really here is on carefully. Publicity around CAV typically generates over enthusiasm and some unrealistic expectations. There may be some successful applications of CAV technology, but there can be more failures as the technology is pushed to its limits. Really, the limited information equals limited research. I'm not talking about the amount of research we're doing. I'm talking about the scope of our research. Research up to this point is mainly case-based, and it focuses around discussions on how companies have implemented the technology. That's of primary interest to researchers. And as a result, the research questions are narrowed really to particular situations in order to understand the technology. At this stage, publicity is mainly about the limitations of that technology. The regulatory developments are reactionary, and they're usually a quick fix in response to, valid but often unsubstantiated concerns. The situation really becomes quickly muddied, and as the system really strives to adapt and change, we are realizing those unpredictable and unintended effects, and they can tend to predominate and slow down the system development, and which, if left unchecked, can lead to a vicious cycle that further damages the system. So I could go into some of these examples on the slide. You got the Elaine, I can't pronounce her second name, but the incident of the Volvo in the US and turning down the sensitivity of some of the systems on that vehicle, so it didn't have so many disengagements for etc. And this is exactly the sort of argument I'm making here on this particular slide. The challenge, therefore, of regulating autonomous vehicles as such is we need to identify an approach which addresses the tension between innovation and regulation in a way which maximizes the potential benefits and minimizes the potential risks. I mean, when I wrote this, I thought to myself, that sounds very, very simple. But I think actually it's far more nuanced. First, we have to agree on what we actually want to achieve from introduction of CAV. From a policy perspective, the headline may be we want to reduce harm, but equally, we may want to increase the efficiency of the mobility system, or we may look at generating economic activity off the back of technology developments. However, the issue is not only which measures are important, but how to measure. As an example, would a step up in system safety, which is often talked about when we, in the context of connected autonomous vehicles, if we can actually agree on what that step up actually should be in the first place, would it merit a deterioration in the outcome at a lower level? I.e., if we can basically drop the headline killed and seriously injured from road traffic, would this, on the flip side, would this justify the introduction of new accident types somewhere else in the system? And whilst a less complex problem, the same discussion is going on around smart motorways at this very time. And there's a number of headlines I see day in, day out around different commentary on smart motorways. In addition, and beyond that, once we can agree on that question, we have the issue of identifying the most appropriate mechanism to achieve the above, and more on this anon. So the traditional approach to regulation is primarily it's an instrument for delivering policy where the market is unable or unwilling to do so. Policy in relation to the mobility sector, as mentioned previously, is to target a minimum level of protection to both user and environment. Hence, really, the role of regulation has been to remove the worst performing from the market or to establish a minimum performance requirement for market entry. It is not necessarily about innovation per se. In this way, and with good regulation, I mean, the oft-used phrase here is technology neutral, the market can be left to decide the ideal technology solution. And it's typically one that balances the user need against the ability of the industry to deliver. Indeed, the requirement for actors in the given market to be able to differentiate between themselves actually drives the innovation. So better safety, offering lower emissions, or offering improved autonomy, etc. In this way, i.e. allowing the actors to differentiate and only setting a minimum performance requirement, we actually have the laggards become the core become the stars. In effect, by setting a minimum performance requirement, we actually move the entire market distribution to the right, as shown on that diagram on the slide. And the Japanese Top Runner program, if people have heard of that, has taken this to its logical conclusion. And the Top Runner program really looks to set the minimum standard based upon what is achievable in a given sector, i.e. it looks at what is possible given the technology available, then works backwards to establish what the minimum acceptable requirement is. It's a bit like that Arthur C. Clarke comment I mentioned earlier. By setting the benchmark or the top runner as being connected and autonomous, we can work backwards and we can set the minimum market entry requirement in that example given by Arthur C. Clarke as saying, if you don't have connected autonomous vehicle capability, you're not allowed to basically be part of the mobility market. So what is the best mechanism really to deliver The most conservative regulatory approach to rapid technology change, as we're experiencing in this sort of sector, is to slow the development of a new technology. I mean, this approach, referred to as the precautionary principle, is commonly reduced to, we're better safe than sorry. Until we understand it, we'll basically keep it at arm's length. The assumption is that it's best limit or halt the commercial adoption of an emerging technology until really it can be explicitly shown to be safe, or we have generated sufficient information to calibrate a proportional regulatory response. It reduces the likelihood that such frameworks will need to be amended based upon new information regarding risks or any sort of trajectory of an emerging new technology. So that's the precautionary. The second one is, we can have an approach of inaction, to let the system develop along its own lines without additional controls being put in place. So we rely on what's already there. Common sense really would suggest that inaction would increase both the probability of accidents and so the severity of public fallout. So if we have vehicles in the fleet of varying different ability, and we extend the difference between the ability of the best performing and the lowest performing vehicles in the fleet, then it's logical that we may actually introduce new accident types, which would basically damage public trust. In addition to legal uncertainty, regulatory inaction can also, undermine public confidence in the safety of a new technology. So precaution not necessarily has the best approach. Inaction also probably a weak approach. The third response really is to be more proactive, perhaps, and to enact future-facing proactive regulations that attempt to anticipate or otherwise perhaps shape the development of an emerging technology. I mean, proponents of this response acknowledge there's limitations of regulatory institutions, but, and I classify myself as one of these, is they view regulation as an important element in the success and safety of new innovations. They maintain that because regulatory institutions struggle to react and adapt to rapid changes in emerging technologies, regulators really should be looking to design frameworks which can anticipate or attempt to guide their ongoing and future developments. These would include what I would term adaptive regulatory approaches. And these adaptive approaches, as a concept, rely more on co-design of regulation standards through deep engagement with those stakeholders that are affected. They help me as a regulator understand the nuances of the technology and its potential impacts. In particular, adaptive regulation will avoid the pitfalls of static mandates by responding to, rather than locking in or implicitly anticipating specific evolutions of the autonomous vehicle technology. Basically, instead of making an educated guess as to the most likely or desirable development path of autonomous vehicle technology, an adaptive approach allows for continual adjustment based upon the generation or the continuing generation of real world data, of active debate, and of changes in market and society in general. So to finish off, really, I'll provide an example, sort of food for thought, so to speak. In this example, we have a pedestrian. It's crossing in front of a connected and autonomous capable vehicle. The next question really is, what do we expect to achieve from the vehicle? We will assume on this case that the sensors have correctly identified the pedestrian, and that is not always necessarily certain. However, even though in this case they've detected, those different systems on the vehicle may provide slightly different results. I know the text is small, but if you could read the slides, it would give you a difference of between 10 meters in front of the vehicle and 12 meters in front of the vehicle, depending on what system you're looking at. And this 10 to 12 meters can make a significant difference to outcome under certain conditions. And by certain conditions, I suppose I'm referring to, the level of risk that this situation presents. You note I haven't basically given the speed of the vehicle, or I haven't given the speed of the pedestrian is crossing at, but I expect for a given combination, the risk will be different if we take the distance to be either 10 meters or 12 meters. So one could result in a A minor collision, one could result in a more severe collision between the vehicle and the pedestrian. So further to this, if we could actually measure risk, so at 10 meters, the risk is high, at 12 meters, the risk is low. The second question I have is then, what risk would be acceptable? If we're looking to measure performance, we need to have some sort of ability to measure so we can assess. I'll give you an example. What if the pedestrian is approaching the edge of the road? They're on the pavement at the moment. And once they approach the edge of the road, they will actually stop. Well, obviously, as the vehicle is approaching the pedestrian and that distance between is continually decreasing, that risk that we measure will increase until that event, until the pedestrian stops at the side of the road, and then reduce. Is it acceptable to allow that risk to inflate? And if so, to what level? We do it in the traffic mix that we experience day in, day out. We basically have a dynamic risk where every action we take has a risk associated with it, and it's not zero. It can get quite high at times, especially in busy urban areas where there's a lot of pedestrian traffic with vehicles moving about. If we set risk to be at such a low level, we will actually end up damaging the system because we will lose public trust, because the system capacity will reduce. And they'll think, well, why is this new technology being promoted when it basically puts the system at a disadvantage compared to what it was previously? Once we have risk, then perhaps we should now introduce mitigation into the equation. And mitigation refers to the action of the vehicle in response to that risk. What should that mitigation action be? What should the relation between mitigation and risk be? Should mitigation be more severe for a higher risk, etc.? So it's two problems really that then present themselves. What is it we should measure? And what should be the expectation, i.e. the minimum acceptable performance? So I've got some concluding remarks. The previous slides have looked to show that there is a relationship between regulation and system performance. And if you don't have regulation, we have a risk damage in the system. Regulation will not slow down innovation per se. Indeed, omission of regulation can lead to uncertainty with the accompanying issues that causes for both the developer and the consumer. However, I do appreciate regulation that is inappropriate for the problem that is presented has the potential to delay. There is therefore really a sweet spot between the two, and it is clear that an adaptive approach is probably what is required. An adaptive approach has the ability to develop in tandem with autonomous vehicle technology. Further, and as noted in the presentation, regulation has driven market innovation indirectly through setting of minimum performance requirements, and this in turn pushes the sector to further innovate to attain product differentiation. However, the complication comes when we look to define that regulation. What should the performance requirement be, considering the infancy of the technology? There is both the risk and mitigation to consider. The ability to evaluate risk and the ability to take proportionate action is what I'm talking about with risk and mitigation. This requires that we can both measure risk, we can measure the action as well, and we can define appropriate thresholds. But how do we set these? As I say, is it going to be a fixed value or is it going to be dynamic depending on condition? One approach proposed has been to base upon existing system performance with a step up. So instead of looking at the granular level, you look at the overall mobility system performance. The question I always have when I listen to presentations is, what is this step up? How large should this step up be? And it's a question of what is acceptable to society, I suppose. And how does this align to user developer expectations? So there, the concluding remarks. I'm now going to hand over for a brief introduction by Kevin.
Thanks, Hugh. Oh, am I live?
Yeah,
Thanks, Hugh. That was brilliant. That was certainly thought-provoking. I'd like to introduce you to Kevin Vincent, Director of the Centre for Connected and Autonomous automotive research, who will be joining us for the live Q&A session. He should appear on your screen any second.
Thank you, Lisa.
There we go.
I think I'm live.
Yeah, we should. I think we're going to be able to put all three of us up there in a moment. And we have got some questions to start with. And I think Kevin's going to start by looking at the one in the question and answers.
Yes, certainly. Thank you. So for those who don't know me, I'm director of the Centre for Connected and Autonomous Automotive Research at Coventry Institute for Future Transport and Cities. Just a little bit about me, my background. I've been with the university now for nearly 12 years, but previously I was 20 years in industry, focused mainly around automotive product development within body structures, lightweighting and safety. So in terms of CAV, my real interest is in how to make them safe. Yeah, and quite a lot of challenges are there. So we have not so much a question, but a comment from Colin Warburton about commending us to the nuclear site license, which he says does not set detailed standards, but demands that the licensee provides adequate arrangements to achieve safe operation. And also that must be proved, and the regulator may prosecute if either the arrangements or compliance with them is not satisfactory. So to answer that, I think that's it's a very good point, and we do have something similar. We're at a stage of CAV development where we have the code of practice, which details how we may trial new products and processes on the public highway. We have CAV Pass in development by CAV and the UK government, and also just literally released this week the Zenzik safety case guidance framework. So all of these frameworks lay out how operators, developers, and companies can do their due diligence and present a safety case to let's say demonstrate that the trials that they're proposing will be operated in a safe manner. I think the one thing that's interesting here, though, is that in my opinion, there's a disconnect between how we trial and forthcoming ADAS and automated systems coming down the pike in terms of, for instance, advanced lane keeping systems, which is in development at the moment. It's just been through consultation, and that is much more of a defined regulation, but perhaps slightly falls down, in my opinion, around the definitions of automation and how we might achieve safe operation, particularly around command and control and handover of control, because it's a level 3 automation system, and we all in the industry recognize that there are some human factors challenges in that area. The other area of interest is in the taxonomy of operational design domains, which is an important factor in setting out how we do safety case frameworks. So the operational design domains taxonomy was released in August, and that allows you to set up the environment and operating conditions to demonstrate when the vehicle and the operator are allowed to operate autonomously. So I think the answer to your question is that there's a number of frameworks in place that are maturing. So at the moment, this is still early stage development, and I think the building blocks are in place to achieve something not dissimilar to what you're proposing around looking at the nuclear site license. But I definitely think it's worth having a look at that site license and looking to see where we can get some, say, cross-sector learning.
Thanks, Kevin. We've got another one in saying, I don't think you answered the one underneath that, did you? It was how are regulators approaching regulation for fully autonomous vehicles, and will there be amendments to our current regulation, or do you foresee entirely a new instrument being developed?
I don't know, do you want me to answer this, or Hugh, would you like to step in and have a look at that one?
I think it's going to be a sort of blending of the two. if I'm completely honest. We, with the regulation, as I was trying to point out in the presentation, are trying to achieve policy objectives of creating a safe system. Now, there is regulation and there is standards. And standards are basically looking at how to ensure the vehicle meets its functionality requirements when it's in deployment. And that's slightly different from regulation, which has the purpose of basically meeting society objectives. And I think, as Kevin was mentioning with all these activities going on, there will be a blending. And I think regulation will step in where there is going to be a deficiency or a real problem that is causing an issue out in the traffic mix in the actual deployment of these vehicles. And I just sort of like to also answer your one on the sort of nuclear one. I can't see the questions because if I did it, it will cover the slide that's been shown on my screen. So I'm trying to do this on sort of memory. Now, the difference here is the complexity of the environments and the number of and the capability of the different actors in that environment. I'm not saying nuclear is complex, don't quote me on that. I'm far from the point. I'm just saying that you're trying to deploy a technology into a system mix which has a complexity level which is, in my mind, a huge step up. You have vehicles of different capability, you have other actors in the mix as well. So that is one of the complications that I think that whilst the nuclear example is a good one, I think it would have to be rethought about and restructured in the context of a very complicated mobility system.
Thanks for that, Hugh. Another question for you. How introduction of CAV technology can be implemented to create a mutual cooperative mobility system between technology and eluctable labour job market? You want me to read that again?
No,
Okay.
I think I understand that. If I've understood the question properly, the market often looks at CAV or CAM. So we tend to use CAV and CAM interactively now. So CAM being connected and automated mobility. And so mobility as a service is well understood now, and it's about creating a seamless journey. So how can you move from one modality to another? It's automated and you know where you're going. So this is less about automation, it's more about connectivity. So we need the connectivity to ensure a safe environment that is seamless for passengers and operators to understand what data is being transferred. That data needs to be safe and private, and it needs to operate the system efficiently. So if we get the CAV technology right, then we can have safe, accessible, and inclusive mobility across a wide range of modalities. And what is interesting here for me, I think it's something I've promoted for a little while now, is how, for example, if I wind back a few years to when Vince Cable announced the CAV program back in 2015, I think it was, he did that in Coventry, and there was some heat and light from sectors such as sort of, taxi cab drivers who felt that automation might take away job opportunities. I prefer to look at it in the way that it offers opportunities to upskill. So if you've got mobility system as a service, that you have opportunities for drivers to upskill and offer greater customer service. So it becomes more of a customer-facing role, and that you're not getting rid of jobs, you're actually creating new jobs because you have a wider service offering within MAS.
Thank you. We've got another one. How much input should automotive manufacturers have into the regulations and the development of the mobility systems? And should it be a global approach rather than a national approach?
Well, in terms of the input from the automotive sector, I think there is three ways of looking at the regulation. And I think the adaptive regulation at the very bottom of that slide is co-investigation or co-production. This technology is moving at a pace. I think the regulatory arena, which is basically relied on evidence collection to set regulatory frameworks, is going to be found wanting going into the future. So I think there is a role there for co-production. And to be honest, co-production of regulation has happened in the crash arena in the past anyway. It's just that the ultimate decision doesn't lie with the OEM, but the OEM does have technical input. In terms of what that sort of role should be for each of them, there is a sort of measure of caution in the fact that we need to have something that ultimately is hands-off from the industry in setting the final regulation. So we can do it for the benefit of society ultimately, but with the industry's input.
I couldn't agree more, to be honest, Hugh. And what one of the things with, I mentioned the ALKS regulation just now, and it's quite clear it's really quite a technical regulation that doesn't quite look at how the human might interact with the system. So having a non-automotive look at the legislation is important. And I think the second part of that question is also important. Should it be a global approach rather than a national approach? So working with bodies like Zenzik, we've looked at regulatory harmonization, and it is recognized that harmonization of regulations is vital. But there's a caveat to this, in that different regions take different approaches to the regulation. So some are more hands-off, some are more directed. So while we might be homologating in Europe, in the US they're self-certifying, and the problem there is finding a middle ground. So I recently I was on a panel with a colleague from NHTSA, and I was promoting regulatory harmonization, and we agreed to disagree on some of the ways that we might do that. So there are challenges to harmonization, but absolutely, if we want to accelerate take up of automated mobility at scale, we do need a global approach.
Thank you. We've got quite a few questions, so I think we've got time for a couple more. Don't worry, if we don't answer your questions here, we will put the answers up on the when we produce it afterwards. How about, what do you consider to be the challenges associated with regulating security in autonomy?
I'll leave that to Kevin. That's a bit left field from my sort of interest area.
Yeah, no, I'm happy to take that, because there's ISO 21434, which is in development at the moment, to look particularly at cyber resilience in these systems. So there's a broad spread of stakeholders and actors developing that. It's particularly, that one is been input by Peter Davis from Thales, who's an ACE member, so ACE in the Automotive Electronic Systems Innovation Network, are taking a large role in developing 21434. The real challenge that I see is how we validate these systems, because we're no longer moving in. If you look at the traditional engineering V curve, the system is validated once it's been developed and leaves the manufacturer. And as we move into CAV and CAM, that's no longer going to be the case. We're going to need to validate systems ongoing through their product life. So in other words, you're going to need through life product assurance. So these vehicles have got to be compliant, and their owners have got to be assured that they're compliant. The MOT system will no longer be fit for purpose. So there's a whole raft of challenges in there. When you have vehicles that are receiving over-the-air updates, we already know that sort of, over-the-air updates can change, for example, the way Tesla manages its battery pack for cybersecurity. How do we know that over-the-air updates don't have an unforeseen consequence on the systems and firmware in the vehicle? So that's a massive challenge and we need a new way of thinking about how we do verification and validation. It needs to be both digital and physical, and there needs to be some form of sort of diagnosis and prognosis ongoing with the vehicle during its life, and that's a very big challenge.
Thank you. I think we'll try and squeeze one last one in. There's one from Wayne on the screen, Kevin, if you can see it. It is one of the biggest one of the biggest barriers is EV infrastructure, and there's not enough charging infrastructure, and there's 4 different charging variants, and he lists all the variants. I think you can see that. I think I was looking for a comment on that, really.
Yeah, that's the challenge here is how we conflate EVs and automated vehicles. And a couple of years ago, I think the general consensus was that automated vehicles would be EVs. I didn't happen to follow that. There's no reason why an automated vehicle should be an EV. IC engines and vehicles are perfectly happy to be completely automated. There's no problem there. But what changed the landscape was now the direction that by 2030, all new vehicles have got to be electric. So now the two things are completely conflated. We need new ways of thinking about how we do EV infrastructure, how we challenge the hydrogen versus electric argument, versus battery argument, for example. Are we looking at hybrid systems, and how do we charge them? And I can't see a way myself that we can have a simple 3-pin plug commonality in this area, because it's just not mature enough. So we're going to have to be carrying around different charger connectors for quite some while. But the worst thing we face at the moment is maintenance. There was a case recently where an owner took 9 hours to drive from the Isle of Wight to, because they had to go around the houses to see where they could find a working charger on the motorway network. And where they couldn't find one, the operators, who were mostly petrol stations, had no idea that they were even not working or how they could maintain them.
That's really common, isn't it?
Yeah. So it's not just that there's enough charging. There isn't enough charging infrastructure
that work,
enough that actually work and are being maintained properly. So there's a chicken and egg. We need mass adoption at scale of EVs before we can get an infrastructure that actually works, because there's no incentive to take that asset and manage it when its usage is not there.
Thank you, Kevin. I'm going to have to round it up there. We're running out of time. But I just want to thank everybody for joining the event, and I hope that you've gained a broader insight into the regulations around connected autonomous vehicles. The MTI is here to help your workforce upskill and reskill within the areas that we've discussed today. And please do visit our website if you want to view what courses we have on offer and to find out about our up and coming events. And please connect with us on LinkedIn. That would be great. I'd just like to thank again our speakers for today. Thank you, and for attending our webinar.